I am Shivji from Nutanix, and I'll be talking about how you can stream the changes in your app to an event store. I am a platform engineer with specialties being databases, streams, service-oriented architecture for applications and infrastructure. I love distributed systems and open source. I am a committer in Apache Pulsar and an active community member. I have contributed to MySQL in past. If you like this content, you can find these slides on my SlideShare account, so you don't fret about taking notes. If you like this content and want to watch some of my other talks, I have been doing a lot of talks lately. So you can find all those slides on my SlideShare, and video recordings of some of my latest sessions are also there on my YouTube channel. This is my Twitter handle and LinkedIn. I'll leave all my social media handles on the last slide. So whatever questions we can take here, fine. Otherwise, you can always reach out to me here or even in Hopin. I'll be there for a moment after the session. Let's start the story with the days of monolith. Um, so let's take the example of an e-commerce app for the whole flow of this session. Let's say you have an e-commerce app, people come and order for stuff. Then there is a CRM section where if they have a query with something that they ordered, they can leave a question there or maybe talk to somebody. And then maybe you have a fulfillment um, section in it where the orders are actually delivered. So all of these will now stay in one code repository in your monolith app. Behind the monolith app, you have one database, which is probably a monolith database, and you store all your data there. Typically, for your analytics team, what you want to do is you don't want to disturb the production database and an application. You want to make a read replica of some sorts, and on that read replica of that database where all the data resides, analytics teams or your ML team can come and train their models with that data. Your BI teams can have a look at that data and sort of draw some fancy graphs to aid your business side. That was all good world. Then we moved over to microservices. And microservices are distributed systems. Distributed systems is hard, but the reason we moved to microservices and summarizing it, it's like you break that application apart into one order management application, one CRM application, and one fulfillment application. So all of these have separate code bases. They are deployed separately, scaled separately, but all of them also, in our interest here, have separate databases, probably even separate database servers. So now your data is fragmented. Your analytics teams can probably have a distributed query engine, excuse me, like Presto, or as it called TrinoDB these days, or you can have a Flink SQL setup where you can map catalogs of different databases and stuff. But it's still different databases at different locations. So getting data from all those places and joining all of them at one place is difficult. Imagine if your order service uses MySQL, your CRM uses Postgres, and your fulfillment for delivery and stuff uses MongoDB. Now you also have three different query layers, right? So to get all of them together and for analytics teams to know all those query languages of different database vendors is difficult. Maybe you can get all that data and cache on Presto or Trino, and you can query there faster. But it's difficult. So typically, analytics teams will love you if you can get all those data from different transactional databases or OLTP databases like MySQL, Postgres, and MongoDB and stuff to one event store where you look at changes made by transactions in all these databases and stream all those changes to one event store. Why do you want to do that? Because you have these use cases for event store which are going to help your business in big way. First of all, data warehouses like Snowflake, Redshift, and BigQuery. Data warehouses offer you storage as well as compute and all sort of querying. Data lakes probably only storage, and you need a specialized team to get that data, rinse it, store it in a certain way depending on the query pattern, and maybe index it and stuff. So that is a lot of work for every compute or query use case. Data lake houses are this third use case in between, where I think Databricks has popularized this a lot, where they're not as expensive as data warehouses, but they don't require as much work to do as you have to do in data lakes for computes and queries. Now, our last use case that we will talk about is CQRS. CQRS is command query responsibility segregation. So typically, in a lemon language, what you want to do is you want to do all your writes at one place, but the reads happen at the other place. So you have to make sure that anything that is written on this command side, the right side, is propagated to query as quickly as possible, and like changes flow through seamlessly without being lost. This whole process of getting data from these different transactional databases and putting it up in the event store is called change data capture. CDC is the popular acronym for it. What is it? How do you define it? I think this is a three-step process where you have to first identify what in in that transactional database do you want to put at event store. It's not like you want to always have all the data from all those database servers of order management and CRM and fulfillment, like complete databases dumped in event store. You don't want to do that all the time unless you really need it, because keeping duplicate copies of data is storage, extra storage is costly. Moving data around is IO, that is costly. Network is costly. So you want to be judicious about what do you need on the event store. You can identify those pieces of data in different domains and uh, capture those data, and then you have to deliver it to the event store. Typically, if you look at the how of CDC, there are two uh, broad ways in which you can do this. CDC is sometimes only used in this second, but I will in this session use it for both of these use cases, both of these ways of doing the CDC. So the first way is where you go to your order management in our example, and CRM and fulfillment, and in their code bases. So for, let's say, order management, you have a code base where you have a code for creating an order or modifying an order. You go to that exact code and write down code to send the summary of all it, packed it in a event, and maybe put it in a streaming solution like Kafka or Apache Pulsar, and restore it on the event store. Or you can tail the database. You forget about the application has a database, and like something like MySQL or Postgres, and then you take the database, probably transaction logs, and then you try to see the change in every transaction and restore, stream it to your event store, and recreate the state there. In the first case, where you write code, the good thing obviously is that you're writing code, you know your code, you have good leverage. Let's say in the CRM case, you have a query for which you don't really need the CRM data, you also need order data. If there is a problem with a order, then you need the details of that order for order management. So you collected that data. Then in CRM, you have order history for this user history maybe as well. So you get all of that data to make a decision. You don't store all of that in the database. You probably only store CRM stuff in the CRM database, the current thing that we are going to do, just capturing the decision. But all of that together, CRM and order management data, in packed in a self-sufficient message inside an event and sent to event store, actually has a lot of benefits. So that is good thing to do. The bad thing is that you have to actually write code for each and every event, and it gets furthermore complicated if you have an application. Again, that e-commerce application is already running, people are ordering, you are doing good on business. Suddenly now your product management team sees that we want to be data driven, we will have an analytics team. Analytics teams now need data. So now you want to go to every application and fetch data from there, and now you want to stream it to the event store. So now for the product manager to go to every application team and schedule tasks to code up those events is actually difficult. In this case, if you have a central team, a platform team, which can make a CDC sort of a pipeline to fetch data from all the databases, tailing them, and even for new databases that will come in future, they will hook up to this CDC pipeline and throw in data to your event store. That will be great. Mostly the delivery happens asynchronously if you're writing code. But if you have a business critical application where you want your event store to be updated all the time, or you have a CQRS sort of a pattern where query has to happen on the latest data, then you want to sort of do it synchronously. Maybe extra latency is okay for you in that use case. Secondly, I described it a little bit. You can tail transaction logs, which is write a log for Postgres, bin log for MySQL, and all of that. You can control it from the platform team, one central CDC pipeline for all the databases, no extra code, no extra latency, completely decoupled teams and applications for CDC and app. And then there are standard tools like Debezium. Debezium works for MySQL, Postgres, MongoDB, all of them. Maxwell works for MySQL. You can use that. They're pretty standard tools. The bad thing about this is MySQL has its own format of storing a transaction log. Postgres has its own. MongoDB has its own. These can change across database upgrades, so you have to keep track of all of them. DDL changes propagating to event store is difficult. If you have a case where maybe DB crashed after writing to transaction log and didn't apply to DB, maybe you send it over to your event store and you're doing your querying there. So you have a ghost transaction and ghost data there. That is a problem. But you can also do it in a clean way, tailing from the database using something called Outbox Pattern. In the interest of time, I will skip too much details about Outbox Pattern, but I have put a link to the blog where I found a good explanation of this. But in a nutshell, you have this order management application. Let's say you write to your Postgres, that's a transactional database. This is your transactional table. So you write all your transactional data here. Whatever you want to put to event stream, you put it in an outbox table. You have an outbox in your email app, and then you have your CDC pipeline consisting of Kafka Connect app that pulls changes using Debezium, then pushes to Kafka, or it could be Apache Pulsar or something, where you put all your change events from different domains, and then your event store can go and consume this. The whole CDC pipeline and all those things probably could be avoided in most of the cases if you can use this evolving landscape of databases, which are hybrid databases, which support both transactional workloads as well as analytical workloads. And the examples include a single store DB. It's a closed store database. It used to be called MemSQL DB. They rebranded themselves as single store DB these days. PingCap is an organization that has TiDB. MySQL has something called HeatWave, which allows you to have a query accelerator, and that will facilitate your transactional as well as analytical workloads. Whatever blogs and articles that I found doing the research of this talk, I have put in references. Just short talk, so I couldn't cover everything. And let me know if you have questions in the Hopin platform.